welcome to today's webinar, Getting Started with AWS IoT. Our presenter today is John Rota. John is a software development engineer in AWS IoT, focusing on devices and SDKs. In the past 4 years, he has been working in the field of IoT, helping people from makers to manufacturers get their devices connected to the cloud. Today with us, we also have Janish Varia, Senior Technical Program Manager for AWS IoT, Badri Pani, Software Development Engineer for AWS IoT, and Ben Moore, Senior Product Marketing Manager for AWS IoT. Janish, Badri, and Ben will engage with you and answer your questions throughout today's presentation while John presents. John, welcome. I now pass the floor to you.
Great, thanks, Pawan. Hi, I'm John. I'm an engineer on the AWS IoT team, and I'm going to talk to you today about getting started with AWS IoT. Today's webinar is going to have an overview of AWS IoT. There's a lot of components involved, and so I'm going to try to hit each one from a high level and kind of give you a grounding of all those components. And then we're going to build a working demo. We're going to go end-to-end, install one of the SDKs, create certificates, get it connected, and actually try to build out a use case. And then at the end, I'm going to show that use case actually working on some hardware in our lab. So we got a little video of that. So let's just jump into it. This is an overview of AWS IoT. AWS IoT is a managed service for IoT devices to connect to AWS services. So if you have devices in the field and you want to use, maybe you're already using AWS services and you want to get that device data into those services so you can use them maybe in your business applications or a mobile app, you're able to do that. So let's just walk through some of the components and give you an idea of what that looks like. The first one we're going to touch on is security and identity. Security and identity have two main points I want to touch on. One is strong authentication. So each of your devices are uniquely identified with the service. And that's important for a couple of reasons. One is just so you know exactly what device is connecting. And also, it allows you to scope policies down to each device. So you can do things like a device is only able to publish on its own topic. And it doesn't have permission to do other things, maybe destructive things like delete things. And so that becomes very important when you have, if you ever would have a situation in which the credentials were maybe lost or compromised, you want to limit the scope of what that device can do down to just its actions, and that helps you limit your the radius of what would happen if something like that would happen. The other component is securing the communication channel, and so what we've chosen to use there is it's a web security standard, TLS, and we've used mutual authentication. So a device would have a certificate, and it would present that certificate to the service, and that's what we use to uniquely identify each device. And we're using TLS 1.2, the latest TLS standard, and the strongest cipher suites. So you can be assured that that communication channel is secured. There's no eavesdropping or man-in-the-middle attacks. The next component I'm going to talk about is a device gateway, and this is where we're able to scale these long-lived connections to our service, from up to millions of connections, billions of connections. This is what handles all of those and manages those connections, and then there's a layer underneath too that's a brokering layer that ends up passing the messages between the devices. If you have a device that wants to publish and a device that's subscribing, that's the layer that we use to pass messages between the two. The gateway presents a couple of standard protocols we've chosen to support for IoT. The first is MQTT, which is a lightweight protocol for IoT devices, and those are long-lived connections, so they're a TCP socket and you're passing messages back and forth over that socket. And then there's HTTP also, so you can do things like just do posts or gets, just like a normal HTTP protocol. The device gateway is the front end for all these AWS services. So you can think about this as the first thing that your device would communicate with when it's talking from the field. These are all we're able to present long-lived connections and in a scalable manner. The underlying architecture of this is topic-based, so we leave the topic space in your account open for you, so you're able to architect it to what your use case may be. And I've just given a little brief example down there at the bottom where you can see I organized the topic structure as maybe you have a campus full of buildings and you have different units in there that are connected to the service. You can organize it by building, and then the next layer down would be what type of device that was. And then down to the individual unit. And when I show you rules in a minute, it's going to make more sense on, things will start to click on how you could architect your solution to be able to pick certain things out using topic patterns. The next component is a device registry, and what this allows you to do is tag devices with some metadata. And so instead of just having a plain ID in the system, you can do things like, you can see here I've got some CLI output, AWS CLI output, and also how we'd expose it in the console. And you can see one of my devices I've tagged with something, just some metadata like a model number or a serial number, or even maybe a maintenance date or when it was installed. And so that's always something that lives with the device or with a thing in our system. The next concept I want to talk about is device shadows. You can think of device shadows as a persistent way to store state of your device in the cloud. And so it's a copy of your device's state in the cloud and allows you to do things like program against this shadow from an application. And when you're programming with your application, you don't have to worry about things like connection status. Is my device currently online? I need to, maybe I would need to communicate in a different way if my device is offline versus online. As long as you write your applications to address something like the shadow, then your applications, the interaction is simple. It's a simple write to the shadow or maybe a fetch from the shadow. And then the synchronization takes place. It's disconnected from that shadow. So when a device comes online, we would sync that shadow state. Or maybe if it was already online, it would get that update immediately. And so I've got a little thing to walk through to maybe kind of make this more clear of what the shadow interaction would look like. Over on the right side, you can see a shadow document, and these can be up to 8K in length, so you could have many parameters in there. And I'm just showing maybe an example of, say, an engine, and you can see some things like tire temperature or tire pressures and things like that. And one of the things I want to highlight showing an entire document like that is if I was to perform a write from a mobile app, maybe I only want to change one of those parameters. I just want to set something like the engine is on. And you can see that all it had to do was write that one parameter. It didn't have to know the current state of everything. And so it wrote that one parameter. And one of the things you can see that happened in the document was we set the desired state of the engine to be on, so you can see that that was changed. And then you also can see that down at the bottom, the shadow generated a delta. And what that means is the last reported state of the device was the engine was off. And we just programmed we wanted it to be on. So there's a difference there. There's a conflict of what we want the device to be and what it was the last time it reported. And so now when I go to the next slide, we're going to simulate that, let's say the engine comes online, and it connects, and it says, I'm currently off. When that happens, we're going to sync down to the device and say, sometime when you were offline, someone had programmed you to be on. So here's the delta that you missed. And so presumably at that point, the engine would start itself, make sure it's running, and then it would report back and say, I'm now on. And you can see when it reports back that we've resolved that delta, and now that reported and the desired states match. And so it's a really powerful concept that you can use, one, to disconnect your app development from your connection status of your device. And it also allows devices to, when they're offline and have intermittent connectivity, they can get their current state when they come back online. The next concept I want to touch on is the rules engine. And you can think about this as the link from the AWS IoT service to all the other AWS services. So if you're going to do something like you wanted to take your device data and put it into a DynamoDB table, you would write a rule that would look for that data on those messaging topics, and then you'd have an action that would write that into DynamoDB. One thing I want to touch on rules is it's a really powerful concept to be able to have, say you've got a device and you have it programmed to send something, some sensor value from the field, and then you install it in a location where you're not going to go out to and maybe change the parameters of it. You can change the behavior of that device just by changing the rules. So let's say you've got a situation where you've got a device, it's reporting some sensor value for you, and maybe you want to say, maybe you realize that, boy, we really could take advantage of something like machine learning. You can just write a new rule to change the direction of that data flow, or maybe fork that data flow and send it to another service and take advantage of that without having to change device firmware, without having to change any of the other applications. You can just start adding rules on to take that data and place it somewhere else. So let's take a quick look at what rules look like and maybe a couple of use cases you could use them for. You can see I've got a series of devices there, and they're all publishing on these topics, and this is kind of the topic structure I talked about earlier, where we've maybe got a campus of buildings, and you can see all the buildings, and then we go down a layer to the type of device, and then maybe the actual individual device for those topics. And under our IoT service, you can see that there's a SQL statement, and this is what the selection statement or the SQL statement looks like for when you're building a rule. And you can see what I've chosen to do is basically what I want to do is take all my building one data and I want to put it in a DynamoDB table. So I was able to write a simple SQL statement that just says select all the messages from that topic, anything that starts with building one. And you can see the pound sign in MQTT, that's a wildcard. So I want to select all of my building one data. And what I want to do with that is put it into DynamoDB. And it was that simple to take all of those streams of data, grab the ones that you want, and stick it into a DynamoDB table. So another obvious use case for rules would be alerting. And you can see for this, what I wanted to do is say across all of my buildings, so another wildcard in MQTT is a plus. So you can see that I want to say I don't care about the building, and what I want to key on is anything that's got a chiller, and then any of the chillers. And so I select from that topic match, and then I look for anything if they report a value where the coolant is less than 20. So if that happens, that's a bad situation, I'm saying, and I want to do something with that. And so if any message in chillers comes in where the coolant's less than 20, here are the things I want to do. And the two things I wanted to show here was one, the concept of you can have multiple actions for a rule. So if you want to, maybe you have a rule that sends all your data to a data store, and then you also want to do something in a Lambda function, you can do both of those things off of one rule. And what I'm showing here, and another thing I wanted to highlight was, one, I'm showing a Lambda function, so we're sending those things to Lambda. And two, like the second thing is I'm publishing to an SNS topic. First of all, the Lambda thing I want to call out is, in this use case, I'm just presuming that that's something where when this Lambda function runs, it's able to gather some context around this error. Maybe it can query like the last 10 values reported from that particular machine. And then maybe it could do a post into your ticket managing system and say, here's some contextual data around what had happened. And then also we want to send a message through SNS. We want to send a message to a technician and say they need to come online and see what happened with that particular chiller. And I wanted to call out a little bit here to Lambda also is this is another thing that makes it so flexible for device data that comes into the service is once you get device data like this through a rule into a Lambda, there's so many things that you can write just writing Node.js or Python code and being able to shape that data or do something with it. So it's really, really flexible. The rules engine allows, here's the integrations that we currently support, DynamoDB, Kinesis, I talked about Lambda, Kinesis Firehose, NSQSQ. You can even republish messages back into AWS IoT, so maybe you recognize a condition like that and it actually should post a message to another device, maybe some alerting device or something, so you could do something like that. As the messages go through the rules engine, there's a lot of transformations and little functions you can run just right in the rule. Things like maybe hashing or math functions. You can do some string functions like concatenation. And I wanted to call out one, just doing topic tokens. So you noticed in the example we were publishing on a 3-level topic and it said something like building 1 and chillers and then the unit ID. As those messages flow through the rules engine, you could grab certain things. So let's say you wanted to grab the type of thing, it's a chiller. You could use a statement in your rule and say, give me the second part of that topic. Or maybe you want the device ID, so give me the third part of that topic. And I want to decorate the message payload with that. So as it passes through the rules engine, we would tag on the things that you want to tag on. So some really cool and convenient functions that you can run on top of your rules. So the next component I want to talk about is our device SDKs. And currently we offer 3 device SDKs and then support in both Android and iOS SDKs. And what I'm calling out here when I say device SDKs is there's the functionality allowed to make these TLS mutual auth long-lived connections from these SDKs. And so you're able to, I'll highlight the SDKs and then I'll speak a little bit more about what I'm trying to call out there. So first is the C SDK, and that's something for a more deeply embedded application, maybe something with an RTOS that's running on a microcontroller, like these battery-powered devices. Our Node.js SDK is great for the embedded Linux platforms. So you have something like a Raspberry Pi or something, and this is a great way to write in a high-level language like JavaScript, and then still have access to hardware, so you can still do things like read sensor values and actuators, maybe turn on a motor or something like that. And that's actually the SDK I'm going to be demoing today. And then there's the Arduino Une SDK. So if you have some Arduino sketches and you're familiar with prototyping with an Arduino Une, you could use this SDK, and it makes it really easy to connect from that device. And then the highlight on the mobile SDKs is that it's just adding if you want a real-time data stream using an MQTT connection, we're adding that support to our mobile SDKs as well. And one of the things I wanted to call out, something that we see posted to our forums, is asking for support in other SDKs. And I just wanted to call out that all of the other SDKs are Java, Python, Ruby, Go, those SDKs, PHP. They already have support for things like getting and putting to thing shadows and any of the certificate APIs. So when you're building an application and you're going to have a workflow where I create devices, I create certificates, maybe I'm changing rules or updating shadows, all of that support already is in the our other AWS SDKs like Java and Python, so those are already available to you. AWS also offers starter kits, and so there's from a variety of manufacturers. We have a starter kit that you can order from Amazon.com, get hardware in your hands. We've already tested our SDKs on this hardware, so you know it's something that's going to work. It's just a wide variety of these two. We've got kits from like a Broadcom and a Marvell where you would run a C SDK, and it's a more deeply embedded application. Devices like the Intel Edison or BeagleBone Green from Seed Studio, and the Dragon board from Qualcomm and Arrow. Those are perfect examples of embedded Linux platforms, things where you could get a shell, you can actually maybe drive some video with it, and perfect for our Node.js SDK. So a wide variety of these, you can order these today on Amazon.com. It's just a great way to get up and going if you don't have the hardware already. For the demo, when I show you the video of the demo we built, I'm using the Node.js SDK. And I just wanted to call out 3 of those starter kits that would be great for exactly this demo. The one I chose to use was the Dragon board from Arrow and Qualcomm. But you can see we'll distribute these slides, and there's links there to the store where you can buy these starter kits. These are 3 great examples of what you could use to build the demo I built today. And also, I can't go through this slide without also acknowledging a very popular board that you could use for something like this is a Raspberry Pi. So that's another option also. So here's just a quick overview of the demo hardware I built this demo with. When you see the video, you'll see this board in the background. It's got a Qualcomm Snapdragon processor, so it's quite a high power platform. It'd be great. It can run Android or Linux, so you could do something. Maybe you're building like a kiosk or some sort of like touch-driven application. It'd be great to have Android on there. Or maybe have something. You've got this digital signage thing. You want to drive a display with some video, and this would be great for that too. So now we talked through all the components. Let's actually walk through and build out our use case. And I'm going to do that live on my screen share, and I'm going to just talk a little bit quick about what that use case is. And this was a fun story actually. We had a customer come in as a director for IT at the company that we were talking with, and they're looking to implement an IoT solution at their company. But this person in a former job was an engineer, and he likes to tinker around with things. And he said, you know what, I've been playing around with this stuff at home, and I'm just trying to understand it. And the use case I was trying to do is I've got a little pool in my backyard, and I need to manually turn on and off the pool pump. And I thought, this seems like a great little thing. I can just play with this, maybe make a little controller that controls the pool pump, and just control it from the internet, and just more to learn than necessarily the functionality. And the problem he presented to me was the device is connected intermittently, so it's probably only online 50% of the time, only because it's on its Wi-Fi and it's outside of his house. And so that was a great use case. I was able to say, we actually the device shadow is a perfect use case for this. It's just device state that you want to have that would persist, and you can just simply write an app that writes to the shadow, and then when that device does come online, it's able to sync, and it's perfect use case for the shadow. And then he said, well, one of the things I'd want to know then is, well, how do I know when that sync happened? I can kind of trust that it's going to happen, but boy, I'd like to get a notification when it does. And I said, well, that's a great use case for a rule too. And so I thought this actually, after we talked through this a little bit, his kind of maker pretend, not pretend, but his learning use case, I thought this would be a great use case. I can probably build this in 20 minutes, and I actually can show it in this webinar. So that's what we're going to do today. The overview of this ends up being, you can see there's the device connecting using the shadow. That'll end up being the Dragon board using our Node.js SDK. And then the application, we're just going to show it in the console. And obviously all of the things I'm going to show in the console are going to have APIs in the backing them. So you'd be able to write, when you actually want to do this programmatically, you're just going to use one of our SDKs and update the shadow or get the shadow. But I'll just show it in the console, and I'll make it, I think it'll be a good visualization and show you how easy it is to get going with it. And then off of the shadow, when we get updates, I'm going to set up a rule that looks for that update and then sends a notification to my phone when that sync happens. So now let's just go and build the use case. And now you can see I'm logged into my AWS console. Let's go into the AWS IoT service. You can see I've got some stuff in here already. The first thing we're going to do is create a thing. So I'm going to go to create a resource. And create a thing. And let's just call our thing pump1. And we'll create it. Now you may be asking, well, what does this thing do for you? I mean, I just created this, representation of my device, but it doesn't really, what exactly is a thing? And for the functionality we have now, I'm going to highlight what creating this thing does for you. So honestly, on a device, you'd be able to create a certificate and connect just with the certificate. But I'm going to show you why creating a thing ends up making a lot of sense in this flow. And the first thing I'm going to highlight is when you create a thing, then it allows you to use the registry. And so I'm going to tag my thing with a couple attributes. And how I can do that is I've clicked on my thing, and I can just go up to Edit, and I can add a few attributes. And so let's just add things like maybe the model number. And the serial number. Let's say maybe install date. So now you can see I've tagged my thing. I've got this metadata associated with it. Pump 1, it was installed on the 23rd. And the next thing we're going to do when we want to connect is we need to create a certificate for this device. And we'll create that certificate, and then we would put it on the device, and that's what it would use to connect. So let's go to create a resource. Excuse me. And then create a certificate. Now you're presented with two options here. Programmatically, if you're going to do this, you would most likely create a certificate signing request on your own machine and then submit the CSR to us, and we would return a certificate through the API. In that way, the private key always stays with you, and you don't have to submit it over the internet to us, and it doesn't have to come back. For a use case like this, like a webinar, maybe maybe you're just getting started, it's easy, just do this one click, and that ends up doing what I just said, but all in the service. So we return the private key and the certificate to you just in one operation. And that's real simple for just like a getting started use case like this. So now you can see I clicked that, we generated a certificate and the private key, so I'm just going to download those. And those just came right down to my Mac. And so I'll go over here. I've just made, you can see I'm just in my temp directory. I just made like a little workspace for the webinar. And I'm going to make a certificates directory, and we'll just stick those in there for now. So now I've got my certificate and private key on my Mac. And the next piece of data I need to do the connection is I need a root CA file. And why I need that is when I'm connecting with my device, the AWS service is going to present a server certificate back to the device that says, yes, I actually am the AWS IoT service. And we need a way on the device to verify, yes, indeed, that certificate is valid. And so what we do how that's done is a root CA certificate. And so you get that through, we have links in all of our SDKs on how to download it, or here in our developer guide, you can see there's a link right here that says root certificate. So I'm just going to download that as well. And if you look, when I hover over that, the link is actually out to the source of the certificate. It's a semantic certificate. So let's just right-click and save that. And let's just go put it in the same search directory. And I'm going to name it something a little shorter. Save it. So then in my search directory, I've got my private key and my certificate and my root CA certificate. And now at this point, since I'm doing this locally on my Mac, a question you may have is, and we see people ask this stuff in our forums, is how do I get my key and my certificate onto my device? And in a case like this where you can actually get a shell and just SSH into the device, it's actually pretty easy. You can just SCP it. It's just a file. And these are pretty special files, so you don't want to be emailing them or posting them somewhere. But if you have an SSH connection or you can do an SCP to the device, you can do something like that. And in the particular case of the Dragon board, it's got a SD card slot. And so actually, when I first provisioned the device, I just copied these certificates onto my SD card and then popped that SD card into the device. So that's an easy way just to transfer the certificates into your device. So now that we've provisioned a certificate and our private key, and I've downloaded all those files, let's go back to our console Let's take a look at that certificate we just created. And you can see it by default it's created as inactive. So the first thing we need to do is let's just activate that certificate. So I'll go up here, Actions, and Activate. And then I'm going to, here's where having a thing also becomes powerful, is I can go into that certificate and let's attach it to our thing. And so now that's more of a bucket or a bookkeeping thing, but when I go to my thing, I can see that here's the certificate that's associated with that. So I don't have to look for this this hash to figure out what certificate I'm associating with that thing, or I'm putting on pump number 1. It's connected to it here in the console. So now that we've activated the certificate, the next thing we need to do is, I had spoken earlier about how each certificate has a policy associated with it, and that's the way that we can create this fine-grained access where you give the device permission only to what it needs to do. And so in order for this device to connect and actually use the service, we need to assign a policy to it. So you do that by just going up to Create a Resource again, and create a policy. Let's just call this pump device policy. And now here you can see the list of all the permissions that you're allowed to give in the IoT service that you're allowed to give to a device. So a logical thing maybe would be, I only want this device to be able to connect and publish, and then under resource you could even say publish to a specific topic. So all you're allowed to do with this certificate is connect and publish to your pre-given topic, or whatever topic you've decided to architect for your device. In this case, I'm just going to select the star, and that means allowing it permission to do everything. That's perfectly fine for a getting started case like this. And just put a star in there too, so that's basically saying this device is allowed to do everything in AWS, in your account in AWS IoT. Say allow. I'll just add that statement and create. And again, this is where in a production scenario where you would end up scoping that down to exactly what you wanted that device to do. So let's go take a look at our policies. You can see we've got a pump device policy, and it's allowed to do any of the IoT actions on any of the resources. So now let's attach that policy to our certificate. So we're going to go find that certificate, and if I go to Actions, I can attach a policy. So there's my policy attached to that certificate. And now that we've activated the certificate and attached a policy to it, we have all we need to actually connect and publish to and subscribe to the service. So let's set up a test client and watch that happen. And just verify we've got all our connections set up correctly. So I'm going to do that with a program called MQTT-FX. This is a Java program that's written to, it's just a Java MQTT client that has a visual interface, so it makes it really nice to interact with the service and see what's going on. And so what we're going to do is we're going to create a new connection. Let's just call it our webinar connection. And we need to put in something for the broker address. Let's figure out how we can see what that is. So when under your AWS account in each region, we give you a unique broker ID that you use, a broker address that you'll use to connect. And you can find that in two different ways. The first is there's a describe endpoint command, an API call you can do, and I've just used the AWS CLI to invoke it. And it's just AWS IoT describe endpoint, and that returns in my region, I said my US East region, what is my endpoint address, and that just returns, here's what we've determined to be, we've generated you a unique address. So I'm just going to copy that for now. But you also can get that in the console, and I'm going to show you how to do that. If I go to my things, into my pump1 thing, you can see that same broker address is right there. So there's two ways you can figure out what your unique connection broker address is. So let's take that, go back to our MQTT client, and paste the address in there. Now broker port, when you create a new connection in this client, it's assuming it's a non-secure connection, and that's port 1883. So let's change that to the standard port for secure MQTT, which is 8883. I'm just going to make up a client ID. Let's just say webinar client. And the rest of this we can just choose the default values. Under user credentials, I want to call out that we don't use username and password in the MQTT connection. So those are blank. Then I'm going to click that SSL TLS, and I'm going to say I want this to be an TLS secured connection. The option for self-signed certificates, these aren't actually self-signed certificates, that's just what this option shows, and this is what allows us to paste in files to use for both a root CA file, the certificate file, and then the private key. So let's go back here. Let's get the directory. For all of those files. Let's grab the name for them. First we'll do our certificate. And let's grab the private key file. And this is just telling the client where can I find my private key and my certificate in that root CA file when I want to make my connection. All right. These are PEM formatted certificates. Just say apply to save it. And now we can go up here to webinar connection and create a connection to the service. And so you can see the green light came on, the connection was successful. There's a little lock there that shows us the TLS session. And I'm going to subscribe to a topic, so let's just say in these topics, the topic space is open, so you don't need to make a topic or create a topic before you use it. You can just say, let's just subscribe to webinar test. And if I go back to, you can see that subscription was successful. If I go back to publish, I can say, I want to publish on webinar test. And we got that subscription. Let's try that again. And I got my hello there messages. Let's try maybe one more time. And there's hi again. So now that we've used this client, we've verified that we set up our certificates correctly. We've assigned a policy that allows us to connect and publish and subscribe. And another thing I wanted to call out here was it's really handy to have an MQTT client like this set up so that you can debug when you start to go into things like writing code and using the SDKs to connect a device. It's really good to have a working client just so you can connect and subscribe and see, yes, my client was, my SDK got connected and I'm able to publish. So it's a good way to not only verify that you set up the certificates and policies and things like that correctly, but it's good just to have it anyway. So when you move on to working on a device, then you've got a client you know works that you can connect and debug. So now that we're that far, let's grab the Node.js SDK and get it set up to use these certificates and connect. So to do that, I just need to go out to GitHub. Let's grab this URL. And just clone that repo. Now we can just go into that directory. And this is a node package, so we're going to do an npm install and pull down all the dependencies we need and build them. So that'll take a little bit. And then after this is done, I'll show you what the examples look like and show you just some general configuration stuff. All right, that's done. So in our examples directory, you can see there's a couple of examples that we've included with the SDK. This device example is just a simple MQTT publish and subscribe example. We've got a thing example that shows just a simple interaction with shadows. And then this temperature control example is a more deep example that has a couple interactions with shadows and actually puts up a little UI that mimics a temperature controller. So a couple examples to get you going quickly. I'm just going to copy over for this. I've already written the code for the example we're going to use, so I'm just going to copy that over, and then we can walk through that and highlight some of the API calls we're going to make in the SDK. So this sample file that I'm showing now is, I'm going to highlight a couple changes I made, but it's basically the file that you'll see in the video that was running on the board. And those changes are just simple things around, obviously my Mac doesn't have access to GPIOs, so you can see here in my get GPIO function, I just commented out the point where I actually did the write to the GPIO and just logged that I wrote it. And then likewise, when I ask for the status of the GPIO, on my Mac, I just commented that out, and I'm just going to take an argument from the command line is what I want that state to be. So let's start from the top of the file. Here you can see where I'm specifying where this SDK, when I run this program, where is it going to get my credentials, where is it going to find that root CA. One thing I still do need to fill in is I didn't know what that certificate ID was going to be, so I've got a little placeholder for it. And so let's just fill that in first. And there's my ID. All right, so now we specified where we're going to get the private key and where we're going to get the certificate. And you can see I specified our root CA certificate. I specified the region. We're in US East 1. I had already put in my endpoint address, but this would be the same thing we used as in MQTT FX. So let's go down a little bit. You can see here's my my GPIO functions that I had written. And the first thing we do when this program runs is we're going to go out and get the initial GPIO state. So you can think of this in this pump controller example. This would be, I just powered up, and what's the pump currently doing? Is it currently on or is it currently off? So I'm going to go out and get that. And then I'm going to build a JSON state that I'm going to post to the shadow. And so what that ends up looking like is my reported state of my pump is what I just queried from the GPIO. And then when I connect, I'm going to register for my thing. This is the same thing that was in the console, pump 1. I'm going to register for that. And what that means for shadows in this SDK is I'm interested in any of the messages that would be associated with that thing. So any of the update messages, if I would get a delta, you'd seen the delta in the previous example where if the state differed, we would send a delta message down to the device so it knew it had to change something. This register is saying I'm interested in any of the messages that are pertinent to this thing. And then finally I'm going to, after I connect and register, I'm going to send that update. I built my initial state up here. I'm going to send that as the first thing I do. So I power up, I connect, and I said, okay, I queried that the pump was on. I'm going to send on to the shadow. So if we go down a little farther, when the device sends an update to the shadow, it's going to get messages back, whether that update was accepted or rejected. And when those happen, we call it a status event. Here's what I want to do when I get one of those messages. And for this example, I'm just printing what I got from the service. What we do on Delta is the important part of this. This is where the functionality really is. And what I'm saying here is when I get a Delta message, I'm going to look into that message and see if that message contains a pump mode in a state, and that is on, then I'm going to set my pump to on. And likewise, if that state includes off, then I'm going to set my pump to off. And you can see in each one of these cases, after I successfully set my GPIO, I'm going to send an update back up to the shadow and say my reported value for that is now on. If I set it on, I report that it was on. And so that'll clear the delta. So let's close out of this, and let's run this example. And I'm just going to say that first command line parameter is off, meaning that let's just pretend like the pump starts off and the pump controller comes online and the pump is off. So you can see that it recognized the pump was off through my command line parameter, and then it posted to the shadow and said pump was off. And then you can see it also received an accepted message by the shadow that said, okay, I accepted the update that you reported that you were off. And so let's interact with that. Let's go back to our thing. So here's our thing in the console. And you can see initially it said no state when it was just initially created. Now if I refresh that, we'll see that reported that we just had gotten from our device. And you can see that the reported state for the pump is off. So let's change that. We can go in here. And I'm going to change the desired value of the pump to be on. And so what this is going to happen is it's going to update the shadow. And obviously, since these values differ, the shadow is going to come up with a delta. And it's going to push that delta down to the device. So when I do that update, you can see we generated a delta, and what the intended value is on. And then that also went down to the device. You can see it received a delta. It saw that the desired was on, so it changed on, and then we did our little set the GPIO and turned the pump on. So let's try that again. Let's set it to off. So we go back in here. We're going to set our desired state to off. Do that update. You'll see that it got the delta. It turned the pump off, and then to synchronize the state, it said my reported state is now off too. And so if we go back here, we refresh our state, you can see that we're all in sync. I desired the pump to be off, the pump turned itself off, and then it reported back and told me that that happened. So that's great. What about the use case we were talking about before? Let's say the pump was offline. So I'm just going to stop that program and pretend like we lost connectivity. So now what happens if I go to update the shadow and I want to say we're going to desire it's on? We're going to update that. And you can see this is going to stay out of sync. And if I go into here, when I bring it back online and say that I'm off, you'll see that's when it gets the message and it syncs. So we've built all of our demo except for the rule part where we want to get that notification. So let's try to do that. So I'm going to go in, I'm going to update shadow to be off. bring this back online. It's going to sync and it's going to be off. And let's create a rule. So I'm going to go into our create dialog. We're going to create this. I'm going to look for, so in our thing, when we send messages to the device, here's the topic in which we're sending those messages. So I'm going to put that in there. And I'm only going to look for messages where they were accepted. And what I'm going to look for is when the reported state for pump mode, that's what I'm going to try to query out of those messages, and also something called client token, and I'll talk about that in a little bit. And what I want to find in that message is if that pump is reported to be on. And so then I can say what my action is I want to publish a push notification to my phone. I've already got that topic set up. And then we choose a role for that and just add that action and then create that role. And so now when I do the shadow update, we'll see a message on my phone. So let's go to update the shadow. We'll see when I bring this online, it receives the delta, it changes the mode to on, and then you can see on my phone I received a message from SNS saying that sync happened and our pump is now on. Okay, so now I'd like to show the video of this working in the lab, and I can talk through what was happening, and it's basically the same scenario, but we'll be able to see we're actually going to use the device and turn on and off this desk lamp. And so this is where this stuff really becomes kind of cool, because you're actually interacting. This cloud software is actually driving something, and you're changing some state in the world. So you can see the device down in front. That monitor is just the terminal output from that device, and then you can see my Mac driving the shadow here in the foreground. And so that was me starting the device. And I'm going to go back, the same thing I did before. I'm going to go to the thing, and I'm going to change the desired state to be on. So we'll just edit desired state, and then I'll hit update, and you can see the lamp in the background when I hit update. The device received the message, and it drove that lamp to be on. And this is also a fun thing to look at and just see how the latency on when I hit the update to the shadow. And so we'll go back. You can see the device synced it. It went back into sync. And now we'll just do the same thing. I'll program the device to be off, hit update again, and it'll turn the lamp off. And so, Ryan, we can probably stop the video now. And so that was building the use case. You can see in a little less than 20 minutes we built an entire use case, had a rule, had shadow interactions, used the SDK. Things I want to call out now in closing are, here's our general info page for where you get the developer guide I showed, where you get example rule topics or rule SQL statements and things like that. And the last link I think is really important to call out. That's the AWS IoT forum. And if you have specific questions after this webinar, you go back, you're getting started with the device, or you have maybe some in-depth questions about how you would use a rule to do something. Engineers from the AWS IoT service actually answer questions in this forum, so that's a great resource for you to get your questions answered. And I just close and say thanks for your time today. I hope it was useful.
Great. Thank you, John, for the great presentation, and Janish, Battery, and Ben for answering the questions throughout today's presentation. So audience, if you can take a moment now to fill out 3 poll questions to the left of your screen, your feedback can help us improve our webinar programming. So we have about 2 minutes to till the end of our presentation. I believe we apologize in advance that we cannot get to everyone's questions, but as John said, we have forums, and you can always email to aws-webcast@amazon.com if you have any suggestions on this webinar, as well as any upcoming webinars you wish AWS may cover in future programs. We'll give 1 to 2 minutes for everyone to have a chance to provide feedback to the poll questions to the left. And thank you again to our audience for taking the time to join us today. Enjoy the rest of the day.